8.6, Part 1, Solving Exponential and Logarithmic Equations. So here in example 1, we're going to solve an equation by equating exponents. So in other words, getting the base of both sides of the equation to be the same. Right now we have 27 raised to the 2x power, and we have 9 raised to the x plus 2. So my base over here is 27, my base over here is 9. Now, if I think about that for a minute, I can tell that they are both factors of 3. So I'm going to rewrite each power with a base of 3. So 27 is the same as 3 cubed, and 9 is the same as 3 squared, right? 3 cubed is 27, 3 times 3 times 3. 3 squared is 9, 3 times 3. So now I have to get my exponents together. So we have a power of a power, so that 3 to the third raised to the 2x is the same as 3 to the 6x. Multiply the exponents when you're taking a power of a power. And then over here I have 3 squared raised to the x plus 2. Now I have to be careful that I make sure and multiply that by both of the factors. So that becomes 3 to the 2x plus 4. So now I have the same base on both sides, so I can equate the exponents. So on the left-hand side, my exponent is 6x. On the right-hand side, my exponent is 2x plus 4. So now I take that and I go ahead and solve for x. So 6x equals 2x plus 4. So I would subtract 2x from both sides. That gives me 4x equals 4. And then divide both sides by the coefficient on x. So x equals 1. So my solution is x equals 1. And I would check that by substituting back into the original equation. So 27 to the 2 times 1 power, is that equal to 9 raised to the 1 plus 2 power? Okay, so that would be 27 squared, which if you do that on a calculator or on paper, you get 729. And 9 raised to the 1 plus 2, or 9 to the third, and if you do 9 to the third or 9 cubed on a calculator or on paper, you get 729. So because 729 is equal to 729, the solution checks. Okay, now moving on to example 2. We have solve 4 to the x power equals 21. Now this time we're actually going to take a logarithm of both sides, because in order to get this x by itself, it's an exponent, and the opposite of an exponent is a logarithm of whatever this base is. Okay, so I have to take log base 4 of both sides in order to get that 4 to cancel out and isolate the x. So that would be log base 4 of 4 to the x power equals log base 4 of 21. So that isolates my x. Log base 4 of 4 essentially cancels out, and the x is left. And so I get x equals log base 4 of 21. And since my scientific calculator can't handle logs of varying bases, I need to use the change of base formula in order to use common logarithms. So then that becomes log of 21 over log of 4, which is approximately 2.2. Okay, when I plug all that in. So the solution is about 2.2, and I will check this in the original equation. So 4 to the 2.2 power is equal to approximately, when I do that on the calculator, I get 21.11, which is close enough to 21 that I can reasonably assume that this is accurate.